So in this video we're going to use logarithmic differentiation, and all logarithmic differentiation is a technique for simplifying taking a derivative by using properties of logarithms when the function you start with doesn't have a logarithm in it to begin with. So here I have f of x equals x minus 2 squared over the square root of x squared plus 1, which is the same as raising x squared plus 1 to the half power. And I don't have a logarithm to begin with, but what I can do is take the natural log of both sides. And once I've taken the natural log of both sides, I can then use logarithmic properties to take this right-hand side and break it apart. So using logarithm properties that we saw in the previous video, I can rewrite the right-hand side expression as 2 times the natural log of x minus 2 minus 1/2 times the natural log of x squared plus 1. So it's just applying 2 of the logarithmic properties that we saw in the previous video. And then I can take the derivative of both sides. So once I've expanded the right-hand side using logarithmic properties, I can take the derivative of both sides. And remember, when you have the natural log of crap and you take the derivative, you're going to get crap prime over crap. So, and that's using the chain rule. So on the left-hand side here, to take the derivative of the natural log of the function f of x, I'm just going to get f prime of x over f of x. I'm going to get that crap prime over crap pattern that we've seen. And now I can walk through and take the derivative of the right-hand side, which is going to be 2 times the derivative of the natural log of x minus 2 is just going to be 1 over x minus 2 times the derivative of x minus 2, which is just 1, minus 1/2 times the derivative of the natural log of x squared plus 1 is going to be 1 over that crap. So 1 over x squared plus 1 times the derivative of the crap. So the derivative of x squared plus 1 is 2x. And now I can start to simplify. So one thing I want to notice is I can multiply both sides by f of x to isolate the derivative f prime of x, which is what we're trying to find. So multiplying both sides by f of x will isolate the derivative that we're looking for. And this will be times 2 over x minus 2 minus 2 goes into 2 one time, so minus x over x squared plus 1. And then if I wanted to, I could get a common denominator. So f of x times the common denominator would be x minus 2 times x squared plus 1. And we would be multiplying 2 times x squared plus 1, which would give me 2x squared plus 2 minus x times x minus 2. So that's going to give me a minus x squared, and then minus minus would be plus 2x. And this is going to equal the f of x is just x minus 2 squared. So to figure out what the f of x is, I just go back to the original statement. F of x is this stuff here. So I get x minus 2 squared over x squared plus 1 to the 1/2 power times 2x squared minus x squared is x squared plus 2x plus 2. And this is over x minus 2 times x squared plus 1. And this x minus 2 is going to kill one of those. So this equals, and I'm going to get an x minus 2 times x squared plus 2x plus 2 over, and in the denominator I'm going to have a base x squared plus 1 because both of these terms have x squared plus 1 and they're being multiplied. I'm going to have a base of x squared plus 1 sitting down here in the denominator, and this is to the half and this is to the 1. So a half plus 1 is 3/2. So the base x squared plus 1 will be raised to the 3/2 power.